Okay, it's time for part 2 of our trig review. So when we're looking at this unit circle, we need to figure out the coordinates, the x, y's. There's some that are pretty obvious, like the fact that since this is a unit circle at 0 degrees or 0 radians, you've gone over 1 and up 0. Or at pi, -1, 0. Left 1, up 0. Or 0, 1 at pi over 2. And 0, -1 for 3 pi over 2. So now looking at 30 degrees, I'm going to consider it 30 degrees just because it's kind of more familiar territory. So this is a unit circle, so this distance here is 1 because it's the radius. So I'm going to label that with a 1. Now a 30-60-90 triangle is half of an equilateral triangle. So like basically if you imagine this thing going the whole way down like that, like a whole equilateral triangle, obviously we have 1/2 right here. So then if you know the Pythagorean Theorem, which I know you do, you can find that extra side. X squared plus 1/2 squared equals 1, so x squared plus a fourth is 1. So x squared is 3/4. So x is √3 over √4, but √4 is 2. So now I know that my x is √3 over 2, and my y is 1/2. It follows that pi over 3, 60 degrees, are the same coordinates, but switched. It also follows that you can take advantage of the symmetries. So like 2 pi over 3 is going to be -1/2 and positive √3 over 2. And you could go the whole way around. I'm not going to do that, but it's straightforward. Okay, our 45 degrees though, again, hypotenuse is 1 because it is the unit circle, radius is 1. Now, if you know the Pythagorean theorem from moments ago, and you know that a 45-45-90 triangle has two sides the same, these two legs are the same. I'm going to call it A. I don't want to use X or Y just because variety. So A squared plus A squared equals 1 squared. So 2A squared is 1, so A squared is 1/2, and then A is square root of 1/2, or 1 over √2. Now, there are all sorts of math teachers who insist that it's not okay to leave a fraction as 1 over √2 like this. And they're like, you have to rationalize the denominator and multiply top and bottom by √2 and clean it up, blah, blah, blah. That is some seriously old-fashioned math that has to do with before you had calculators, because what would you rather do? Divide the square root of 2 by 2, so you'd have like 0.1, like 1.4-ish divided by 2, 0.7-ish, or 1 divided by 1.4, blah, blah, blah. So it's a relic to no calculators. We have calculators, we can leave it like this. So now we have our 1 over √2, comma 1 over √2. Okay, so using symmetry, you can get any of the others. I'm not going to do that. So from here, if you need to find sine, cosine, or tangent, as long as you know SOHCAHTOA, and I know you do, you can find your sine, cosine, tangent. Sine being opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And then, so looking at our triangle here, like looking at our 30-60-90, we have the √3 over 2, the 1/2, and the 1. You can just go, okay, sine being sine of my angle here is opposite over hypotenuse, so sine of 30 or sine of pi over 6 is 1/2. By the way, we will always be in radians in this class. I'm referring to the degrees sometimes just because it's familiar territory. Cosine being adjacent over hypotenuse, so cosine of 30 would be √3 over 2 divided by 1. And then tangent being opposite over adjacent, 1/2 over √3 over 2. And we don't have to clean that up either. It's convenient. It's totally fine to leave a truly ugly fraction. finally, the last bit of it is remembering like, oh, secant, cosecant, cotangent, what goes with what. There is a very handy mnemonic that I have so we know that, I'm just going to slide here, or hopefully we know that secant of an angle is 1 over cosine, and cosecant of an angle is 1 over sine. Those pairings are both CS's. My initials are CS and it's all about me. So that's one way to remember it. Also, like, if cosecant was 1 over cosine, that's putting two cos together, and that's cocoa, which is chocolate, not math. No good. And then the other bits we need to know, knowing that tangent is opposite over adjacent, and we know sine is opposite over hypotenuse, but the hypotenuse is always 1, right? So when we're looking at our unit circle, really what it comes down to, knowing that our hypotenuse is always 1, sine is the opposite, which is the y value. And cosine being adjacent, that's our x value. So if you know your x comma y for any place on your unit circle, you know your cosine comma sine. And just like x and y, those are alphabetized, so it's a nice little quick cheat you can use of like, oh, those are alphabetized just like x and y are. And then since we know that tangent's opposite over adjacent, that would mean it's y over x. That means it's sine over cosine. So tangent, I'm going to come back here again, is sine theta over cosine theta. And cotangent, being 1 over tangent, I think we can remember that those go together. So that means it's the reciprocal of tangent. So cotangent is cosine over sine. So if you can count with fractions, you can deal with radians. If you know SOHCAHTOA, you can find all your coordinates. If you know the Pythagorean Theorem, you can get your coordinates. And SOHCAHTOA is going to get you everything else you need. So one of the key bits, though, is the fact that you do need to know the fact that the cosine is the x and the sine is the y, because when you're looking at something like 0, 1, or pi over 2 radians, it's like there's no triangle to look at. Anywhere else you have a triangle to look at, but those you don't. So you have to go, oh, okay, cosine of 90 degrees or pi over 2 is 0, sine is 1. So in a very rapid pace, we have just cracked our unit circle.